Okay, children, we shall move on to the third problem in the exercise 2.3. The question is diagonals AC and BD of the trapezium ABCD intersect at O. What they have given? Diagonals of the trapezium ABCD intersect at O. And in this trapezium, which are the parallel sides? AB is parallel to CD. Do remember, it's a very important point. Whenever you have to prove any sides ratios are equal or the angles are equal in similar triangles, first and foremost we have to show the triangles are equiangular. Do remember, in any case, most of the cases while solving the similar triangles problem, first you have to prove the triangles are equiangular using the properties of parallel lines or the propositions what we have studied in the earlier classes. Unless you show the triangles are equiangular, you cannot proceed with the problem, children. I repeat, any problem when you have to solve in similar triangles, do remember to prove the triangles are equiangular and then say it is similar. If it is similar, then the corresponding sides are proportional. It is must to show the triangles are equiangular. Then you can say it is a similar. If it is a similar, then the corresponding sides are proportional. This is the first step what you have to follow whenever you solve similar triangles problems. It's quite simple. AB is parallel to CD. Immediately you have to recall the properties of parallel lines. What is the property of parallel lines states? Corresponding angles are equal. Alternate angles are equal. Looking at this figure, we cannot identify corresponding angles, but easily you can identify Z. Whenever Z symbol is found in the figure, immediately you have to recall alternate angles. So we get two pairs of alternate angles and one vertically opposite angles. Immediately you can say these two triangles are equiangular. If they are equiangular, then the triangles are similar. This we have proved in angle-angle criterion of similar triangles. And hence the problem quite simple. First we have to identify which corresponding angles are equal. Whenever they say parallel, trapezium, always remember alternate angle and vertically opposite angle. Another clue I will show, if there is a triangle inside the triangle this way and they mention these two sides are parallel, immediately you have to go for corresponding angles and a common angle. Only two cases you will find. Most of the problems will be in these two ways. Either these way triangles you may get or inverted triangles. This way you may get. So if you get triangle inside a triangle, then go for corresponding angles and a common angle. If you have inverted triangles where one vertex is common to both, then you have to go for alternate angles and vertically opposite angles in case if they have mentioned parallel. Not all the time when there is parallel line you can go for this method. But maximum times you find these kind of cases in similar triangles. Either trapezium type of problem or else a triangle inside the triangle. Now let us show these two triangles are equiangular similar. Why should I take only these two angles? It's a question. Look what I have to prove. OA, OC, OB, OD is in these triangles. Sides are in this triangle. So I have to consider those two triangles. Here also I can find OA, OD, OC, OB. I cannot take these two triangles because these two sides are not parallel. And I think you understood why should I take these two triangles only, not the other two sides. I should consider the two sides which have the parallel sides so that I can apply the properties of triangle. So first we shall show those two triangles are equiangular and hence they are similar. In triangle identify the corresponding angles, which are equal angles. Immediately, first and foremost, I can identify vertically opposite angles. It's very easy to identify. Vertically opposite angles are equal. I have taken AOB. Let us consider the angle in triangle AOB. Angle AOB is equal to angle DOC. The reason is vertically opposite angles, vertically opposite angles. Then one pair of alternate angles I can take. Go for Z. This angle. So angle BAO is equal to angle OCD. Reason is alternate angles. If any two angles are equal, then the third angle must be equal. You need not show the other pair of angles are equal. If you show any two corresponding angles are equal, it is enough that the three angles are also, third angle is also equal. Therefore, triangle AOB is similar to triangle. Now it is an important point. Important point. See how to fix the corresponding vertices here itself. I have shown angle O is equal to angle O. Here the second vertex is O. Keep